Hi geometry students! In this video, we're just going to be doing another quick review on all the different skills we've learned related to dilations. So first, we're just going to talk about what exactly a dilation is. So a dilation is a non-rigid transformation. We talked about this in class, but remember when we talked about rigid transformations, such as translations, reflections, and then we also did rotations, that meant that I was changing the position of an object, but I wasn't changing its shape or size. When it comes to a non-rigid transformation, like a dilation, we are maintaining the shape, but not the size. So you'll have the same corresponding angles, you'll have the same ratio of sides, so the shape would look essentially the same, it's just going to be either bigger or smaller. There are two types of dilations. The first is an enlargement. In terms of determining whether you have an enlargement or the other option would be reduction, it's based on what we call a scale factor, which is basically the ratio of the sides from the image to the pre-image. So if the scale factor is greater than 1, right, that means we have increased in size, gotten bigger, which is an enlargement. And then a reduction would be if the scale factor is less than 1, and that means that my image is smaller than my pre-image. Okay. And just as another side note, if you had a scale factor of exactly 1, you would not be changing the size, so that would not be an enlargement or a reduction. Okay. Now we're going to go through a couple examples. First, we are going to work on being able to actually draw a dilation. Now, in order to be able to draw a dilation, you need to know a little bit of information. So you have to be given a scale factor, and you have to be given a center, the center of dilation. So we're going to do a couple dilations using this image. First, we are going to draw an enlargement. So I'm going to give us the scale factor of 3. And let's use the center -7, 7. Right. So when I come over to my image here, I'm going to draw my center in on the graph. That's going to be helpful for us. So where I just put that red dot, that is the center. And then I am going to start dilating. So basically, a scale factor of 3 means that each point of the pre-image is going to now be 3 times as far away. So in order to calculate this, I'm going to find the distance essentially from the center to each of the points on the pre-image. And I'm going to start with A. Now, we don't have to find the actual distance. I don't have to use the Pythagorean theorem or the distance formula. But what I'm going to do is I'm going to say in order for me to get from the center to A, I have to go down 4 units and to the right 1 unit. Okay. So the distance to A prime is going to be 3 times that much because that is our scale factor. So basically, I can take the distance, the vertical distance, and multiply it by 3, and then I can take the horizontal distance and multiply it by 3. So there's 2 ways to go about this. One is that you could just sort of draw this same thing 2 more times, right? So it took me 4 down, 1 over. I could go 4 down, 1 over, and I could go 4 down, 1 over again in order to find my image there of A prime. The other way that I could do this is if I knew that it was, 4 down and 1 over, I could just multiply both of those by 3, and I could count directly down by 12, and then multiply 1 by 3 and go over by 3. Okay, so typically I think people would probably usually do what I did the first time where you go 4 down, 1 over, 4 down, 1 over, but you're landing at the same point either way. And then I'm going to get that out of the way just so that my drawing doesn't get too crowded because I did that in 2 different ways. But I'm just going to follow up and do this 3 more times with D, C, and B. These points T and S, just ignore them. I don't know, that's on the diagram that I stole off the internet, so whoops. Okay. So now I'm going to do this with point B. So to get from the center to B, I'm going over 6 units, to the right, and down 4. So again, my scale factor is 3, so that means I have to do that same thing 3 times from the center. So from the center, if I go over 6 and down 1, it gets me to B. I go over 6 again and down 4, that would get me to S. I go over 6 again and down 4. That gets me to this point at 11, negative 5. And that is where I have B prime. Now from there, I have to do this twice more for C and then D. So for C, we're going over 5 and down 1. So I'll go again over 5, down 1, and then a third time over 5 and down 1. And then last but not least, I have D. To get from the center to D, I go over 2, down 1. So then a second time over 2, down 1, a third time over 2, down 1, and that puts D prime right here. Okay. The last thing for me to do is to connect all the points of this image. So I will just draw a straight line. Now, if you're drawing this and you have a straight line tool, for instance, Go Formative or Pear Deck, or if you were drawing this on a paper, you could use a ruler or whatever the straight line tool is. I unfortunately don't have one, but you can see I did my best there at connecting those 4 points to give me this enlarged quadrilateral. And that is our first dilation. You can double check that you did this correctly by making sure, 1, all corresponding sides are parallel. Okay, so I should be able to look and see, okay, my corresponding sides. So for instance, DC should be parallel to D prime C prime. And it appears that that is true for all corresponding sides. And then to also make sure that the length of every side has tripled because our scale factor is 3. So for instance, I can double check that with DC was originally 3. Let me see. D prime, C prime. Oh, that's 9. Okay, so that's an indication that I likely did this whole thing correct. If you want to continue, you can check all 4 sides, and then you would be certain that you did everything correctly. So that was our first dilation. Now with this same pre-image, we are going to create another dilation, and this time we are going to do a reduction. So again, you need to have a center and a scale factor. So my scale factor this time is going to be 1/2. Right? That's smaller than 1, and so it indicates that I'm going to have a reduction. And then for my center, I'm just going to put it up sort of in the left upper part of this graph, and we'll have it at negative 10, 10. Now, last time we performed this dilation, you found the distance to each of the points on the pre-image, and then you essentially multiplied by 3. This time, we are going to be multiplying each of those distances by 1/2, or in other words, dividing them by 2. So as I work point by point, looking the distance from the center to A, looks like I have to go down 7 and over 4. So if I'm only going half that distance, I'm looking at going down half of 7, or in other words, 3.5, and then over 2. And then I'm going to keep working through all my other points. Count the distance over to B. I have to go over to the right 9 and down 7. So then I'm going to do half of each of those for B prime. So instead of going over 9, I'll go over half of that, which is 4.5. And instead of going down 7, I'll go down 3.5. Which would take me right there. It's sort of already filled in with D, but write that as B prime. Now from there, I'm going to keep working. I'm going to go with point C. So to get to point C, I have to go over 8 and down 4. So then looks like half of that would be over 4 and down 2. And then lastly, we have point D, and this is getting super messy at this point. Sometimes this will happen with your reductions, but basically to get to B, I have to go over 5 and down 4. So let's try going, what was it? It was over 5, so I'm going to go over 2.5 and down 2. And that puts point B prime, point D prime right here. And then I can go ahead and connect them all now that I'm done. And you'll see how I have this smaller version of the same quadrilateral. Again, I can double check to make sure that on my image, each side length is half of what it was on my pre-image. So on the pre-image, we had DC as 3 units, and if you look up at D prime, C prime, it is now 1.5 units. And you can see how all of those sides look approximately parallel. It only looks approximate because I'm not perfect and some of these were half units, but it does look like we performed this correctly. It's about half the size. Okay. And that is how you draw dilations, whether they are enlargements or reductions. Okay. Before we finish, we are also going to look at what we can do if we are given a dilation and asked to find the center and the scale factor. So before you find the scale factor, you're always going to find the center. And the way we can find the center is basically creating a line that goes through corresponding points. So here we have A and A prime. If I were to draw a line, and now again, you can use that sort of line tool if you're on something like paired echoformative. I'm going to try my best to draw a straight line. We see basically the difference. I'm going just right across one unit. So I'm going to draw this line that goes through A and A prime, just sort of with a slope of 1. And I'm just going to extend that out. Okay. And then I'm going to do the same thing with B and B prime, because those are corresponding points. And then you're going to extend those until you see where they intersect. Right? If you don't see an intersection between points, or the lines, then you should keep extending the lines out until they do intersect. But here we already have them intersecting, and we find that they intersect right here at the point -4, 2. And so that is going to be our center. Now, let's say that your image and pre-image weren't lines. Let's say they were some kind of polygon. You could do the same thing, right? You can connect all sets of corresponding points, though after you do 2 sets, like A and B, when you add B or C or D or any other points, they should all also intersect at the same point. Now, when it comes to determining the scale factor, first things first, you need to be very careful that you're paying attention to what is the pre-image and what is the image. because that's going to change the scale factor. So I can see here that my red line, the line closer to my center, is the image, whereas the blue line, the one that's further, is the pre-image. And that tells me that this is a reduction, and I want my scale factor to be less than 1. So if I do this and my scale factor is not less than 1, I know I've made a mistake. When we go to actually find the scale factor, what you're looking at is basically what is the ratio between the distance to the image versus the pre-image. So if you have some point on your figure that is in line directly with the center, that's probably the easiest one to look at. So here I'm going to be using point B and B prime to determine the scale factor. And I want to know the distance to the image from this center is 6. And the distance to the pre-image is 8. So my scale factor is going to be 6 over 8, or in other words, I can simplify that to 3/4. Right? Now, let's say none of your points were like in line with the center, or like in a straight line. So I'm referring to like there's only one dimension of movement. So I only had to move horizontally to get to B or B prime. Well, A or A prime, I have to have a horizontal and a vertical component. And this could be true with all your points, right? You might have that with everything. If that's the case, you only actually have to look at one of the components of that distance. So I can say, okay, I want to see the distance to my image for point A, but I am only going to look at the vertical distance. So you have to go 3 units up from the center to get to A prime. So that can be my distance to my image. And I would have to go 4 units up to get to my point of A. And you would find the same way. I have a scale factor of 3/4. And that just saves you time versus trying to actually find the distance when it has both vertical and horizontal movement. Okay. So now that we have all that, I'm going to just practice real quick writing the equation of a line. So I'm just erasing this and then I'm going to rewrite the scale factor for us momentarily. And I just want us to practice writing the equations of our lines. So for my pre-image, which is line AB, I just want to write out the equation. Well, notice that both of these two lines have very clear and distinct y-intercepts marked on the graph. So I'm going to use slope-intercept form to write this equation, which means I need to find my slope and my y-intercept. So in order to find the slope, I can just count. And let me go ahead and just to make this a little clearer, I'll erase this. But I'm just going to find the slope for each of these lines. And what is a dilation? So the pre-image and image are going to be parallel lines. So I really only have to find the slope one time, even if I'm asked to find the equation of both lines. So I want to look at the rise over run. That is my slope. So to get from A to B, we go down 4. Remember, down is negative, so that's a distance of -4. And then I go to the right 4, which would be positive 4. Okay, so my slope would be -4 over 4, or in other words, that is equal to -1. So I'm writing the equation of my line as y equals mx plus b. I have y equals -1x, in other words, just -x. And then I'm going to add the y-intercept for mx plus b. And the y-intercept of my pre-image is 2. And then before we end, we're also going to find the equation of our image, which is line AB prime. And again, this is going to have the same slope. If you don't believe me, we can look at it on the actual graph, but we have to go down 3 and over 3 to get from A prime to B prime. So down 3 over 3, slope is -3/3 or -1. So see, same slope. So y equals -x again, but this time I have a different y-intercept. My intercept is 1, so my equation is y equals -x plus 1. So there's our video. Hopefully you had all your questions about dilations answered. If you don't, you can go look back to your notes, look back to prior videos, talk to one of your peers, and if you still have questions, feel free to email your teacher as soon in advance of the quiz as possible.